Day 2, adding and subtracting numbers in scientific notation. Find the difference. 5.1 times 10 to the 12th minus 6,300,000,000. So thankfully our textbook already wrote 6.3 billion in scientific notation. So it's just 6.3 times 10 to the ninth power. And just like yesterday's textbook pages, what I wanted to do is I'm going to find the term that has the lower exponent, and that term is our second term, and that exponent is 10 to the ninth, or that power of 10 is 10 to the ninth. So I need to change 10 to the 12th to be 10 to the ninth. So what I'm going to do is I'm going to start off with 5.1 times 10 to the 12th, and I need it to be equivalent to something times 10 to the ninth power. So what I'm going to do is I'm going to break apart 10 to the 12th power into 10 to the ninth power, and I need to say, well, what number or what power of 10 when multiplied by 10 to the power of 9 will give me 10 to the power of 12. And that's just my products rule. So I know that 9 plus 3 is 12, so I just broke it down just like that. All right, and then again, it's still multiplied by 5 to the 5.1. I know I already have my 10 to the ninth power, so I'm good there. Now all I need to do is regroup. So I need to do 5.1 times 10 to the third power, and that's going to be multiplied by 10 to the ninth power. When I see my 10 to the third power, that means I need to move my decimal place 3 places to the right for my coefficient. So it's 5100. And that is my new coefficient. So now I have 5100, 5100 times 10 to the ninth minus 6.3 times 10 to the ninth. And so all I'll do now is I will factor out my 10 to the ninth power and keep my coefficients together. And I'll just go ahead and simplify. So I will solve here. I'm doing 5100 minus 6.3. So I'll go ahead and regroup. Okay, so I have 5093.7 times 10 to the ninth, and that is clearly not written in scientific notation because scientific notation tells us that our coefficient needs to be a number between 1 and 10. In order to do that, then I'll just have 5.0937. So I'll just move my decimal place 3 places. So I'll add those 3 places here. And now I have my final solution. 5.0937 times 10 to the 12th power is my solution. Okay. And let's go ahead and move to the connected problem. So all of this was me answering it first, and then we'll use this to answer our connected questions. Number 2, look at solve it on the previous page. Write the problem with both numbers expressed in scientific notation. Again, I had already done that, and it was here. So all I need to do is have this and copy. There we go. Done. Okay. Number 3, look at picture it on the previous page. Use the table to rewrite the expression you wrote for problem 2. Rewrite that expression so that both terms are written with the same exponent. So again, just like this is what I was saying. So I end up answering all those questions first in order to go back and go really quickly through my connected. So I'm looking for when I wrote them with the same exponent, and it was here. And I will copy and paste that over here. Okay, so I already did all the work on the previous page. Number 4, use the distributive property to simplify the expression you wrote for problem 3. So that's when I factored out my 10 to the ninth power, and that's here. Let me copy it again and move on over. All right. Number 5, write your expression as the product of a decimal times the power of 10. Here we go. We have a decimal times the power of 10. Here we go. Copy it. And then finally, write your solution in scientific notation. And that was our answer that I highlighted here. And there we go. Literally everything we've already done it. Okay. And then the try it is what's new here. So again, I hope that you've already reviewed this or tried it on your own. Now it's just time to review your answers. Number 7, evaluate. So again, our goal is to identify the term that has the lower power of 10 and then change the other one to have that same power of 10. And then of course, once you're done with all of that, put it back in proper scientific notation and you're good to go. So for number 7, the one that had the term that has the lower power of 10 is of course our second term. So we want both of our terms to have the power of 10 raised to the 13th power. So I need to change my first term. So I'll have 7.4. Oh, let me just write that under here. So I'll have 7.4 times 10 to the 15. Oops. Let me break up my 10 to the 15th to 10 to the 13th times 10 to the 2nd, because 13 plus 2 is 15, times 7.4. I will rewrite or reorder it. And then 10 squared times 7.4 is 740 times 10 to the 13th. And I'm subtracting 9.9 times 10 to the 13th. So what I would do is I would then just line up my decimals. So there's no decimal here, so I just add 1 and a 0, and then I just subtract. So that's 730.1 times 10 to the 13th power. And again, I need it to be correct in proper scientific notation. So that means I need to add another 2 decimal places because I need this to be 7.301 times 10 to the something. And since I have to move my decimal another 2 times, I'm just going to add those 2 here. And now my final answer is 7.301 times 10 to the 15th power. All right, if you need to write this work down, please go ahead and do so. You might want to pause, or you will want to pause the video to get that written down if you need it. I'm going to go ahead and erase it now though. All right, so let's move on to number 8. 8.9 times 10 to the 5th power plus 6.5 times 10 to the 6th power. The term that has the lower power of 10 is this one, and it's 10 to the 5th power, so I need to change my second term this time. All right, so we have 6.5 times, and we're breaking apart 10 to the 6th power to be 10 to the 1st times 10 to the 5th power. So we have our 10 to the 5th, which is what we needed. So now we can regroup 6.5 times 10 to the 1st times 10 to the 5th power. That's equivalent to 65 times 10 to the 5th. So now I have 8.9 times 10 to the 5th plus 65 times 10 to the 5th power. And I will factor out my common factor, which is 10 to the 5th multiplied by 8.9 plus 65. So I'll go ahead and add those two. So I've got 73.9 times 10 to the 5th. And again, this is not written in proper scientific notation, so I'll need it to be 7.39. And then I've ended up adding another decimal point here, or decimal place here. So that'll be 10 to the 6th power now. So my final answer here is 7.39 times 10 to the 6th power. And that is all for day 2.